In the topic today, the natural logarithmic function, differentiation. This corresponds to section 3.4 in our textbook. You may notice this is a little out of order, okay? When we went through, we did a lot of the big ideas of differentiation and integration. But we left some pieces behind. Now we're going back. We're going to pick up all those little pieces. So this unit is kind of nice that, we've seen the big ideas before, we've seen the questions. We're just applying these new skills, these new tools from our toolbox. This page is all about definitions of the natural logarithmic function. But we really want to zoom in down here at the bottom. Kind of move this. The derivative of the natural logarithmic function. Derivative ln x is just 1 over x. This can be generalized into a chain rule. Derivative with respect to x of ln u is 1 over u times du dx, so times the derivative of u at the inside. And that really boils down to ending with u prime over u. Now, depending on the problem, this can kind of look different. There could be some more specific things you need to do, maybe more steps. But in general, that's the process. Kind of a quick review of Algebra 2 and Trig and Pickout. Logarithmic properties. So knowing ln 1 is 0 because e to the 0 equals 1. If you have a product, a times b, you can split that up into ln a plus ln b. Excuse me. A power, you can bring that power out in front. A quotient, you can break that up into subtraction. Okay? The reason we're going over this is because sometimes it's useful to rewrite the problem before you take the derivative. Oh, those are really thick. So you remember back when we first did the power rule for differentiation? Sometimes we would want to rewrite the problem before we took the derivative. This is the same kind of thing, okay? Just rewriting the problem, not really solving anything, but making it easier to take a derivative. So 1/2 power, bringing the 1/2 down the front, because sometimes you can get ln of something really, really gross. It can help to rewrite it so you take the derivative of multiple ln's. Each one will be pretty simple. So if we go down to example 2, letter A. Using the chain rule, y prime equals derivative ln 2x, 1 over what you're taking ln of, so 1 over 2x, times the derivative of the inside. Those 2's cancel out, and you're left with just 1 over x. Now look over here to the side, okay? If we did a quick rewrite, ln 2 plus ln x derivative of ln2, which is just a number. Derivative of a number is 0, cancels out. So derivative of ln x, 1 over x. Same thing. So in this example, not a really big deal if you split it apart at first or not. But you can, and you get to the same thing, okay? This one, I look at it initially, I think quotient rule. Maybe expand to the top first, so you get a 5th degree polynomial. Or using properties of logarithms, you could split all of this up. Dx, quantity x squared plus 1 squared, and the root to x cubed minus 1, split those up in 2 separate logarithms with a subtraction in between. Then the top, the x times quantity x squared plus 1 squared, split that up with a plus between them. Now look at the example over here. We've seen this before. Equation of a tangent line. So we need the slope and the point. Oh my goodness. Look at that. We have a point. It's almost like they write these problems to be solved. You know, a certain kind of way every time. So at the point, let's go ahead and get the slope. We need the derivative of this fx. That's going to be a product rule. 1/2 x and ln x squared. Derivative of 1/2 x, just 1/2. Derivative of ln x squared, so 1 over x squared times the derivative of x squared, 2x. Get some cancelling to happen. Ends up being 2 over x. So let's put it all together. No. Old school product rule, get your puzzle pieces, put your puzzle pieces together. So kind of cross multiply, okay? So the ln x squared times 1/2 plus 1/2 x times 2 over x. Well, that's kind of nice. 1/2 x times 2 over x. X is cancel, 2 is cancel. All you have left is 1. So you have 1/2 ln of x squared. That's our derivative. Oh, sorry, plus 1. Don't forget the plus 1. Oh my goodness, plus 1. So now, let's find the slope at -1. So 1/2 ln -1 squared plus 1. So this is a 1/2 ln of 1 plus 1. Now remember, your logarithm properties, e to what power equals 1. With that question mark, I could do better. Okay. well, that's it, I guess. Okay, so e to our power is 1. Of course, e to the 0 is 1. So we have 1/2 times 0 plus 1. We have 1. There's a slope. We need our point. Which I believe is right here. All of this should seem very familiar to you. So now point slope form, y minus rho 1 equals m times x minus x1. Again, it should all seem very familiar to you because we've done it a lot. The same type of question, but now using ln. Same process, you need a point, need a slope, do all that, put it all together. It's number 6, find dy dx, so implicit differentiation, which you've done this before, okay? So nothing really new, just a new derivative rule that you're looking at. So that's for xy. Be careful, that's a kind of sneaky product rule. ln x squared y, you can assume there are parentheses, so ln of x squared times y. So the first thing I would do, you look at the ln quantity x squared y, you think, oh my goodness, what a horrible chain rule problem. Or use the properties of natural logarithms and break that up. So we have 4xy plus ln x squared plus ln y equals 7. Now you have 2 ln, but each one is only of one variable, okay? The 4xy, kind of a sneaky product rule. Call f the first part for x. Let's call g y. So f prime is 4. G prime is dy dx. So now putting all that together, for y, again, kind of cross multiplication. And the for x dy dx plus now ln of x squared 1 over x squared times the derivative of x squared, so 2x. Ln of y 1 over y times the derivative of y dy dx equals the derivative of 7, which is 0. So now implicit differentiation, solve for dy dx, get out the dy dx on one side, everything else on the other side. So 4x dy dx plus 1 over y dy dx equals negative 4y minus 2 over x. We have dy dx in both terms. So pull both those out. You may hear my kids stomping on the floor directly above this room. It's about lunchtime. If you were worried for my safety, thank you, but you don't need to be. And now get dy dx by itself for good. So dy dx equals negative 4y minus 2 over x over 4x plus 1 over y. And on an FRQ, you could leave that alone. On multiple choice, they may look at the fraction inside of a fraction and think that's kind of gross. They want to tidy up a bit. So knowing how to do the algebraic manipulation. So to get rid of the denominator x, multiply each term by x. But what you do to the top, you also get to do to the bottom. So this will take care of the x denominator in the top. To get rid of the y denominator in the bottom, multiply by y. But again, what you do in the bottom, you get to do in the top also. Because again, you can only multiply the fraction by 1. We're not changing the value. We're only changing how it looks. So negative 4xy squared minus 2y over 4x squared y plus x. Alright, any examples I haven't gone over, take a look at those. Check your work with my complete notes online.